Okay, so now let's make a summary, okay? Now, what happened when we don't have this example? The previous example was when we have the hyperbola centered in the origin, that we have that we are going to have the distance A is going to be the distance between the origin and the vertex, okay? This is going to be the vertex, this is going to be the other vertex. And here when we have a vertical one, we are going to have that A is going to be vertical from the center to the vertex. Okay, the distance between these two is going to be equal to 2A, and the distance between these two is going to be equal to 2A because this is A, so this is also A, so this is going to be 2A. Now, C is going to be the distance between the foci and the vertex, okay? So all this is going to be called C, and all this is going to be called C. So the distance between the two foci is going to be called 2C. Okay, the distance between the two foci. So now let's make the summary of the equations and see what happens when it's not centered in the origin, okay? So when we have the equation centered in the origin and when we have the equation in a center h comma k. Okay. So now the equation for this hyperbole, the one that it opens right or opens left, is going to be x squared over a squared minus y squared over b squared. But what happens when it shifts? When it shifts, we are going to have x minus h squared divided by a squared minus y minus k all squares divided by b squared equals to 1. Okay, here I missed the 1, sorry. Okay, so here I missed the 1. So this is going to be when it's centered in the origin and when it's out of the origin. Now the equation for the coordinates for the vertex, we have that is plus or minus a, comma 0. When it's shifted, we are going to have that is the vertex h plus or minus a, comma k. Here it's not going to be 0 because it's not in the origin, okay? It's in the coordinate k. And now we have the foci. The foci are going to be plus or minus c, comma 0. We are going to have, when it shifts, we are going to have that the foci is going to be h plus or minus c, comma k. Okay, so take a paper sheet, please, and write these formulas, this equation, because are going to help you a lot. Now, the equation for the asymptotes is going to be plus or minus b divided by x times x. This is going to be the slope, remember? So it's right over wrong. And when it shifts, we are going to have y minus k equal to plus or minus b over a times h x minus h. Okay. So this is when the hyperboles opens left or opens down, okay? So now when the hyperboles upper, so upper right or left, when the hyperbola opens right or, sorry, opens up or opens down like this, we are going to have different equation, okay? Okay, so now when the hyperboles opens down or opens up, we are going to have a different equation, right? So when it's centered in the origin, we are going to have that the equation is going to be, it's going to be y squares over a squares minus x squared over b squared equals to 1. And where is shifted when it's out of the origin in h comma k, we are going to have the equation that is y minus k squared divided by a squared minus x minus h squares divided by b squares equals to 1. Okay, so now we have this equation that is out of the origin. Now, what happened with the vertex? In the origin, we have 0, comma, plus or minus a. And when it's shifted, we are going to have that is the vertex h, comma, k plus or minus a. The foci, we have like the foci, when it's in the origin, it's going to be 0, comma, plus or minus c. And when it's out of the origin, we are going to have that the foci is going to be h, comma, k plus or minus c. Okay, we only need to add the coordinates in this case. Okay, instead of 0, we are going to write the h, and instead of only c or minus c, we are going to add the k. Now for the asymptotes that are the imaginary lines, we are going to have that is plus or minus a divided by b times x. And when shifting, it's going to be y minus k equals to plus or minus a divided by b times x minus h. This equation is going to be the same one, even if it's open right, left, up, or down, okay? And let's remember that c squared is equal to a squared plus b squared to the difference of the helix, okay? So now let's make a problem when they give you an equation that is not centered in the origin. So now x minus 3 squared divided by 4 minus x plus 2 squared divided by 9 equals to 1. Okay, which is equals to 1. So now let's start with finding a, b, or c, okay? First, first we can know where is the center, right? The center is going to be in h, comma k. So as h is negative, so we are going to have that it's going to be 3, comma, as this 2 is positive, we had it in the negative number that is negative 2, okay? So the center is gonna be 3, comma, minus 2. Now, A, how do we identify which one is A? We can know which one is A, knowing that is the one that have the positive value, okay? So this one have a positive value, so this is going to be A. So A is going to be the square root of 4, which is 2. And B is going to be the one that is negative. So B is going to be b, which is equals to the square root of 3, that is the square root of 9, which is 3. Okay, so b is equal to 3. Now let's find c. Okay, c squared is going to be equals to a squared plus b squared. So c squared is going to be equals to 4 plus 9, because those are the squares, equals to 13, and c is going to be equals to the square root of 13. Okay, so now we have found A, B, and C. Now let's find the vertex, okay? We can start graphing using this, okay? So we are going to start graphing. First, we need to plug the center. The center, as I said, was in 3, comma, minus 2, right? So 1, 2, 3, 1, 2. So the center is going to be something like here in 3, comma, minus 2. So here we can start graphing. We know what is the value of A and what is the value of B, right? So we have the value of X 2 and the value of B 3. So A, as A is done of the X, here is going to be related with the X coordinates. Okay, so we have A is going to be 2, so we will do steps to right, 1, 2 here, and 2 steps to left, 1, 2 here. To graph this hyperbola, we need to create a rectangle. Okay, and B, we have that is 3, right? So we go 3 units down and 3 units up. So 3 units up, 1, 2, 3, uh, like here, and 3 units down, 1, 2, 3, something like this. So now we can create a rectangle. Let's create a rectangle with these points. Now that we have the rectangle, we can create the asymptotes, okay, that are going to be the verticals, the diagonal lines. Okay, this green one that I drawing here is going to be the asymptotes. I took a paint course to make this. Frank, you there? Okay, so now we have the center. We need to find the vertex. Okay, we need to find the vertex, and the vertex are gonna be in edge, comma, plus or minus A, comma, K. This is going to be the center. So the center is going to be equals to 3. That is the edge. We have this one in 3 plus or minus 3 plus or minus A, that is 2, which is equal to 2, and K is equals to minus 2. So we are going to have two vertex. One vertex is going to be equals in 5 comma minus 2, and the other vertex is going to be in going to stay in 1 comma minus 2. 1 comma minus 2. Okay, so now let's look the vertex. The vertex I want to stay right here, here, and here. Now let's find the foci. The foci is going to be in H plus or minus C, comma K. So we're going to have that one foci is going to be in 3 plus or minus square root of 13, comma minus 2. Okay, these ones are going to be the foci. And the equation for the asymptotes, we have the equation for the asymptotes going to be plus minus k equals to plus or minus b over a times x minus h. This is the slope, remember, b over a. So now we have y minus k is minus 2. So as k is minus 2 and this is a negative number, we're going to have y plus 2 equals 2 plus or minus 3 over 2 because b is 3 and a is 2. X minus 3. So now realize that y plus 2, this is something that we have previous in the equation, okay? Here, y plus 2. So it takes similar to the original equation. So now that we have the vertex, we create the rectangle and we have the vertex, we can draw the asymptote. We can write the we can write the hyperbolas very near to the asymptote. So let's write this with correct. And we are going to have something like this. And also here, not touching the asymptote, but very close to it. So here to the center. Now we have graphed the hyperbole, and now we have all the data. Okay, we have the vertex, the foci, the equation for the asymptotes, and we have also the center and the foci. Okay, the foci are going to be in 3 plus the square root of 13. The square root of 13 is like 3,5, something like that. 3,6, 3,6. So 3 plus 3,3 is going to be in 6. So we are going to go 6 units. More than a half to the left from the center. So 1, 2, 3, 4, 5, 6, like here. And the other one to the left. So it's going to be 3 minus 3,6. So it's going to be very near to the y-axis. Okay, here we have the foci. So remember that the distance between the two foci is going to be called 2c, and the distance between the two vertex is going to be called 2a. Okay, so until here, the explanation of today. So let me know if you have any question and I can help you. If not, let's go ahead and work in aleks. Okay.